So let's jump into it. You're given this composite function, b of h of g of f equals this. So fill in the blanks to decompose the composite function. Pay attention to the variables given. Oh, okay, I see. So starting from the inside out might be easiest. So we know our first function is f. So when we follow the variable, like find where x is in here, that kind of guides us to our inside layer. So our inside most layer is f, which is 4x. So f of x is 4x. Then working our way out from that, the next function is not f, but it's g, or just outside of f is g. So then outside of the 4x, what's the next layer? What's the outside piece of that? And that would be ln of something. So ln of the inside. So ln of something, and they said pay attention to the variables. That means we're going to plug in u in place of the inside of the natural log. So then that was g. Now we work our way out to h. So if g was ln, then we work our way outside of the ln to get to the sine. So we have sine is h, but we want to make sure we have the right variable. Notice the v inside the parentheses there. So we use sine of v, and then working out, we have b on the outskirts, the total outside, which is the power of 2 right there. So we'd have everything squared, and that everything is represented with w. So that's it. Those are all the layers. Let's go to the second question here. Given this function, we are finding the derivative. So we have to use chain rule here, here, and here. So for each function. So I'll kind of just write these out. These are just like solid, like basic chain rule problems. Good ones to practice. So 2 to the 3 to the x will have a derivative, or sorry, 2 to the 3x has a derivative of 2 to the 3x times ln of 2. That's the derivative of the outside there. And then the inside layer is 3x, and its derivative is 3. So that's basically the first part. Then we move on to the minus sine of e to the 4x minus 1. So minus sine has a derivative of minus cosine, because the derivative of sine is cosine. And then we leave the inside argument the same. Okay, and then we multiply by the derivative of the inside. The inside layer is e to the 4x minus 1. The minus 1 will eventually go to 0, so we don't need to think about that. E to the 4x has a derivative of e to the 4x. And then there's one more layer, the 4x, which has a derivative of 4. So we multiply by that as well. So there were 1, 2, 3 layers to this one. So that's the second part. And then we move on to the last one, the natural log of x squared plus 3. Natural log of something has a derivative of 1 over that something. So 1 over x squared plus 3. And then we multiply that by the derivative of x squared plus 3, which is just 2x. So all of these things together makes up the entire f prime. And so like this first one would go there, second one would go there, third one would go there. Hopefully that was clear. Last part, they say what's f prime of 0? So we plug in 0 for x in to everywhere we see x in this derivative. Wonder if we could do that real quick. I have no idea. We'd get 2 to the 0, so that'd be 1. So we'd get like 3 ln of 2 for the first part. Then minus, good night. It's a lot of stuff here. So if we plug in 0, yeah, I don't know. It's cosine of 0, which is 1. So I think everything for the second part might just be minus 4. And then for the third part, plugging in 0 would just give us 0 because there's this 2x here. So I think altogether that would be the final answer. Okay, that was that one. We're on, that was the first one. All right, g of x is this function, and they want us to find the derivative using the quotient rule, and then find the values of g for which, or find the values of x for which g prime is equal to 0. So we use the quotient rule, and I don't think I'm going to go through that. I'm just going to find the answer that uses the quotient rule to find the right answer. This is too small. I don't think there's enough going on here either. We want to see b squared on the bottom, so that checks out. A is the top, B is the bottom. They might call them F and G, depending. I don't know. But we're using quotient rule. So we want to make sure we have the derivative of the top in front with b. Oh, these are the exact same. There's just a minus for b, so quotient rule has the subtraction at the top, so b is our answer there. And then x values for which g prime is equal to 0 would probably come from the numerator there. Yeah, that's kind of, geez, that's kind of a nightmare. You have to like take, what do we have to do? We have to like factor out an x to the 5th. Yeah, that's like way too much work. Let's see. I'm just gonna plug this into Desmos. No, let's do it by hand. All right, so if we were to set all of this equal to 0 and try to solve for x, it would be a matter of like really just setting the numerator equal to 0, because if the numerator is equal to 0, then all of it's equal to 0. So it's going to be a little confusing, but I'm going to factor out an x to the 5th from everything. And in doing so, we're left with a 6, 3x to the 5th minus 1, and then minus 1x, and then 15x to the 4th. And that was factoring out x to the 5th from the top here. And then setting this equal to 0, we get this x to the 5th can be equal to 0, which gives us an x value of 0. And then setting this equal to 0, what does that even give us? That gives us, we have to like expand everything. We get 18x to the 5th minus 6 minus 15x to the 5th. We get 3x to the 5th minus 6 equals 0. And we get x to the 5th equals 6 over 3, which is 2. So the 5th root of 2, or 2 to the 1/5, is the other x value. So I think we just got 0 and 2 to the 1/5, which I think looks like that there. All right, so then the unsimplified derivative, what does that mean? Oh, it's the same thing. Okay, sorry. Okay, so we did that one. So that is there, that goes there. All right, and then this last one here. They give us this implicit situation, expression with x's and y's, and they're asking us to find the derivative. So in doing so, this is where we have to tack on a y prime or a dy over dx whenever we take the derivative of a y term. And what we're doing is taking the derivative of all these terms inside here. The derivative of e to the 3x is e to the 3x times 3. That's using chain rule. The derivative of minus 7x squared times y actually uses product rule. So product rule, we have a prime, so I'm going to do minus 14x times b, which is y, and then plus a times b prime, so a is just minus 7x squared times b prime, which is 1, the derivative of 1y is 1, but then we tack on dy over dx. So that's everything so far up to the y. That was the product rule of those two terms. And then just the last one, minus 3y squared, would give us minus 6y. And then we tack on dy over dx because we just took a derivative of a y term. And this is what we're comparing to what they've given us, I suppose. So below are their responses. Bam, 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 bam. And match each student with the correct statement about their differentiation. Okay, so student A, what did they do wrong? So I just want to make sure that, I just want to make clear that these two terms in the middle does match this. It's just they've kept the negative factored out. And that's pretty much it. So their middle term is right, their last term is right. They just left off the 3 on the first term. So left out 3 on the first term. And then the second one, they forgot to do the product rule. So they did not do the product rule here, nor did they tack on dy over dx on the very end. So that's what they did wrong. So no product rule. And then no dy over dx on the last term. And then they did a little too much on this first term here. You're not supposed to subtract 1 in the exponent, nor should there be an x brought out on that first term. The middle two terms look good. They match ours pretty closely, and then the last term is good. So it's really just this first term is a big L. And then the last one, did they just leave off? Yeah, they just left off the last term. They don't have anything going on with the minus 6y dy over dx, but I think otherwise everything is correct with that one. So they left out the last term. All right, that was everything. I hope this makes sense. If you have any questions on anything, let me know. Sorry, I was sounding pretty, just not very enthusiastic. I was just trying to get through this. But I hope this helped. Sorry, I just have a lot of questions piled up. I'm trying to just get through them right now. Anyway, all right.